So how many of you guys were here yesterday's session as well? Almost everyone, I see. Not some. OK. The morning session, the way that it was planned, there was some overlap with some of the sessions that you guys had yesterday. So I tried to make these presentations a little bit more engaging, a little bit more interesting. Probably yesterday you have heard about all the machine learning services we have, what each services do, and so on. In today's session, we are going to talk about the business aspect of it. You have machine learning services. You want to do machine learning. You are a business, but how do you go about it, right? In the machine learning, before technology, it's more about understanding your business and understanding your needs. Well, just for like any other technology, right? So we are going to talk a little bit about how you model your business problem and how to decide where to apply machine learning and how to add value to your business. So what you will get out of this session, you will have a high-level idea of from business model to data collection and processing to model training and deployment. So you will get an overview of the machine learning process end to end and how you can tie that back to your business needs. That's basically the goal of the morning session today. You will also have a better understanding of how to apply machine learning to your business and some example from AWS customers and Amazon.com. So I'm going to share you some example how Amazon.com applies machine learning in its own retail business. In fact, most of these machine learning services that we are building for our customers comes directly from the first-hand experience that we gain in applying those processes and those technologies in running Amazon.com for past 20 years. So I'm going to share some of that story as well. So you must have heard this a lot. Our mission in AWS is to put machine learning in the hands of every developer. So what do we mean by that? So traditionally, machine learning has been only talked about and used by elite group of mathematicians, data scientists, who understand the math very well, who can do the modeling, who understand the statistical modeling, and so on. But in last few years, with the advent of cloud computing and the availability of enormous amount of CPU and GPU, the processing power, now the machine learning technology is at a point where it's poised to add value to the real business, to the real people. Now, that being said, it's not in the purview of the data science anymore. It's more of a commoditized product and service these days, and that's what we want to do. We want to make machine learning as accessible as possible. So if you have done machine learning, if anyone data scientist here in this room, you must have done a lot of statistical modeling using tools like Python, Spark, TensorFlow, Apache MaxNet, and so on. You can still do that in here. But we are also trying to build higher-level services that will allow you to derive value from machine learning with much less effort, even if you do not have a data science team, a core machine learning team within your organization. So you can do that today using some of the high-level services that are available today, and more are going to be announced as we move on. So this is what the current stack looks like. And those are some of the new services. I'm not going to talk through the slides. You must have seen this slide yesterday with all the services. And by the way, these slides are going to be made available to you after the session, so you will have everything. Now, you might be thinking, OK, so we have all these services, right? But how do we start? How do you know, as a business owner or engineer, software developer, an architect within an organization, how do you know out of these big platform, all of these service offering, which one to use? Where do you start, right? That's the question that we are going to tackle this morning. Where should I apply machine learning? So in order to understand that, there is a diagram that I like to share with you, and that is very useful. This shows you the life cycle of the machine learning process. What does the life cycle starts with? It starts with the statement of the business problem. So once you understand what the business problem is, then you need to frame the problem in terms of machine learning. Not all business problems can be solved by machine learning. It's not a silver bullet for everything, right? So first you identify the machine problems that looks like it can be solved, then you frame the problem. You see whether machine learning can be applied to solve this problem, whether it is the right tool. And then comes the big part, which is the data collection. So in a typical machine learning project, data collection takes about 70 to 80% of effort and time. When you are collecting the data, you are collecting from many different resources, you are massaging the data, you are trying to make sense of data. At that point, you are not even using any machine learning product or services. You are just using analytics services, database product, querying, reporting, charting tool to understand your data, prepare your data, running ETL jobs. So that's your next step in machine learning process. Once you collect your data, then you validate, analyze the data. You have to do in some cases, you have to do feature engineering because your data might have a lot of feature, a lot of observation. Not all the feature might be suitable for your machine learning model. So you have to do feature engineering, and once that is done, you have a clean data set that your model that you can feed into your model. Then you start the model training, hyperparameter tuning, and optimization, and that's also an iterative process that takes about another 20, 30% of the time. Can you hold the question for after the session? Yes, thank you. And then once your model is trained, you evaluate your model, then comes the big question that you asked. Are business goals met? If your model meets your business goal, then it's fine. If not, then you go back and iterate from the data collection again, right? So you try to get more data, you analyze data, you try to understand why the model that you created in the first place does not meet your business goal, and you iterate all over again. Finally, you will have a model that will allow you to answer the question that you are seeking for in order to understand, in order to solve your business problem. Then you deploy the model and generate predictions. And that's basically the end of the cycle. But you also have to keep monitoring and debugging your model because machine learning model is based on data. And as your business needs change, as the market condition change, the data changes, every day new data flowing in, your model can get stale. So in order to make the model, keep the model fresh, you need to keep doing this cycle repetitively in a regular cadence, maybe weekly, monthly, depending on how dynamic your data set is. So that's basically the big picture overview of the machine learning process. So let's dive into the first part, which is finding the right problem. How do you find the right problem? So I'd like to share the Amazon.com story here. What you're seeing here on the screen, we call these the Amazon Flywheel. So in this flywheel, you see the main driver of this flywheel is growth. Now, how does the growth happen, right? So the growth happens because of all the activities around it that contributes to growth. And it's like it's a two-way relationship it's like a cause and effect is two-way. Because of the growth, we can provide more selection to our customers. And because we provide more selection to our customers, that results in better customer experience. And when the customers are happy, they have good experience, that brings in more traffic to the platform. And this is Amazon.com story, by the way, right? This is how Amazon.com came into in the stage it is. Because of this high traffic, a lot of sellers come onto the platform. And what does that do to the customers? That provides them even more selection because now a lot more sellers are coming to the platform. And it basically creates a virtuous cycle that goes on. And as the cycle goes on, what does that do to the business? The business grows. And when the business grows, then something else happens that accelerates the growth even further, which is it lowers the cost structure of the business. And when it lowers the cost structure, it also leads to lower prices. So in Amazon and AWS, we always believe in lowering prices on behalf of our customer, which we do, right? So because of these lower prices, it also feeds back to the customer experience. So now customers have a better selection of products and services at a lower prices than competition. And that fuels the growth even further. So that's the Amazon flywheel. Now, why do I share this story with you? Because this is, think about it as a mind map, as a thinking model, a thinking tool. So any business you have, if you think about it, these flywheel, this cycle of virtuous growth does not change. Any business has to find that cycle of virtuous growth that it can keep repeating, and that cycle itself will help the business grow, serve their customers better, and that basically gives them more data point to be able to do machine learning better, right? Because machine learning is nothing but data. And that's why I want to share this story, because at the center of these, that big yellow circle that looks like sun, that's basically the growth. And that growth is the key to success of machine learning and success of your business. If you do not have much data in your business, there is very little you can do even using machine learning. You need the data. So that's what I wanted to share with you. Now, the other way you can also use these thinking tool is to find the places where you can inject value using machine learning. So as we progress, you will see that we will find different points here in these flywheel where we will identify how machine learning can inject value. Everyone familiar with this screen, right? What we are seeing here, we are seeing Amazon.com homepage, the landing page. So once you log into the landing page, today, if you log in, assuming you have done quite a bit of shopping on Amazon, you will see that Amazon will recommend some products for you. Some of the products you might just skip over, some of those might catch your attention. Why do we do that? We do that because we want to provide a more personalized experience for our customers. So if you think back in the flywheel before, the customer experience, right? So this customer experience is, the customer experience becomes better by the selection of choices that we provide for our customer. But how do you do that? Because this is where the machine learning comes into play. In order to provide better selection for customer, and you see that like if you go to, let's say, Prime Video. If you have watched few videos, you will see that it will suggest. And Netflix does that too, right? So in machine learning, the term of these technique is called personalization. How do you do personalization for your own customers? Earlier, it used to be, OK, you need to create a model, like a factorization machine, and you need to wrangle the data. You do the feature engineering. You train the model. And hopefully, the model gives you good results. But today, you don't have to do that. And this is why I said in the beginning that our goal at AWS is to make machine learning available for everyday developers and for all businesses. So today, you can do the same in your business using the service that we provide called Personalize, which was announced in reInvent in the last year. So that's one story. So what does that do? Once you do that, tying it back to the flywheel, it basically allows you to provide better product recommendation, which enhances customer experience. So that's just an example how you can tie your machine learning problem, the business problem, to the machine learning problem, and how you can link it back to the flywheel of growth. Let's take another example. So you see this page. What does it say here? It was automatically, oh, it's too small even for my eyes. It was automatically translated from some different language, from, let's say, German or Spanish or Mandarin into English, depending on your locale. Why is that important? Because today we are living in a borderless world. Businesses and customers from all over the world are selling to all over the world, right? So language barrier is something that might actually curb the growth. So as a business, if you are a truly global business, you would want to break down the language barrier, and which is what we do in Amazon. So let's say a seller who is from, let's say, Germany. Now, the seller can set up their product page in German language, and if he wants to reach out to the English-speaking world, let's say in the US, he doesn't even have to create a product page in English language. We have services that will automatically translate that product description page from the native language to English or vice versa, depending on which way it goes. So that is another example of how machine learning can add value. If you want to do the same today, you do not have to be a data scientist. All you do is just take the service from the shelf which is available, which is called Amazon Translate, and do the same thing for your product, your web page, your documents, or anything. How does that add value? Tying back to the flywheel, it attracts more sellers to come on the platform because it breaks down the language barrier. So we saw two examples, right? In one side, we saw how we provide personalization for customers that allows for better customer experience. And the second, we saw how we apply machine learning to automatically translate languages to attract more sellers to come on the platform, which obviously, again, fuels the growth of the platform as a whole. Another service that was launched last year, reInvent, called Amazon Forecast. And this is particularly important because in any business that are serving customers, there is always a need to understand what the future holds. If you are in a retail business like Amazon.com, we forecast all the time what our product demand will be, how the inventory forecast looks like, which product should we order, how to fulfill, logistics. In every area in a large business, you need to forecast. Now, if you look at the scientific papers for forecast, you will see more than 10 different statistical methods that you can use for forecasting. And all of these statistical methods require you to understand the math behind it, and which is not an easy math. So what we do for that? So first, when we announced SageMaker a couple years back, we started providing inbuilt algorithm on top of SageMaker, and one of those algorithms was Deep AR, which is the algorithm that you use to make prediction based on a time series data, which is what the forecasting is. Today, as of reInvent PAL last year, we stepped that up, and we created a service called Forecast. So what does Forecast do? Forecast makes it even easy. It basically just a drop down at a click out of those 10 different statistical models that hopefully very few understands. If you have some data scientist, maybe he will understand. But now, any developer, any engineer within your organization can just choose the algorithm that he wants to use to do the forecasting on, put the data on S3 bucket, create the model without writing a single line of code. And these can all be done on the console itself. And then it will take about an hour or two, depending on how big your data set is. And at the end, you have a trained model based on Deep AR or any other, like MQRNN or any other statistical model. You will have a trained model. So we try to abstract all the complexities behind this statistical modeling, behind these high-level services. And the forecast service is particularly interesting to me is because even though it is high level, it still gives you a lot of leverage, a lot of tools that you can tweak, even without getting deep into the thickets of the mathematics and statistical computing. So check that out. I mean, I wish we scheduled a forecast workshop this week, but hopefully in some other event in the loft, I'll do a session on the forecast, and we'll show you how you can be doing forecasting more effectively. And when you do this forecast, again, tying back to the growth flywheel, so you optimize your supply chain, and that feeds into the flywheel. It lowers your cost infrastructure because now you are reducing the waste by doing better forecasting on the future demand. So again, this is a third example how machine learning adds value and helps your business grow. So use some tool. This is just an example. So use some tool, okay, to come up with this business model before you jump into machine learning. Try to make the conversation not within the technical folks. Bring in the key stakeholder. Bring in the CEOs, CTOs, product VPs, everyone in the conversation. Build this business flywheel. At this point, you are not even doing machine learning. All you are doing is you are trying to understand what are the key value drivers of your businesses are and how they are related to each other and where you can inject growth that will result into further growth and accelerate this flywheel. Right? So that's the first step. Create a flywheel model for your business. And then find opportunities to add values. For example, how can you save costs through better planning, which is what we saw the example, forecasting. How can you save costs through automating human work, right? So these are just the example. This is not an exhaustive list in any way. The list can go on. This is just a few that I just wanted to share with you. How you can increase revenue by delivering a better product or service. How you can increase revenue by providing a better customer experience. So these are the questions that you will ask once you understand what the key value drivers of your business is. And then inject those into your own flywheel and see which ML opportunity that you identified contributes to which point in this growth flywheel and how the growth is accelerated. So do not get into doing machine learning before you get this nailed. You have to understand what the business value drivers is, because I'll tell you what, machine learning is not cheap, okay? We are providing all these high-level services. We are saying that, okay, we are making machine learning easy for everyday developers. But at the end of the day, machine learning requires a substantial amount of compute power. Going back to my example in forecast, right? So we give you all these 10 statistical models that you can choose from, but when you are training, you are actually using CPUs behind the scene, and that costs you money. So in order to save on cost, do not jump into, like if you have some bunch of data set, do not jump into training into the model. First, ask the right question. What insight does this data can provide me with, and how that can inject value to one of the key drivers of your business cycle. Some common use cases, I think I already have talked through these. Retail, financial services, I'm not going to read everything. Manufacturing, real-time predictions, advertising, you can predict the click-through rate for the targeted ads. Media and branding, you can predict the language and content quality. You can do content filtering as well, which a lot of social media sites that they do as well using machine learning these days. You can do automotive, self-driving, which is, again, the big thing coming. In health and wellness, you can track the progression of the disease. You can use machine learning to analyze the CT scan, X-ray, and whatnot. And a lot of companies have actually proved that those machine learning models can do a better job in analyzing the medical scanning images better than the humans. So these are some of the common use cases. Now, let's take a quick look in the collection of training data. How much data we are talking about here? A lot, right? Why? Because earlier, it used to be your traditional transactional data from your ERP or CRM system or accounting system until about 10 years back. Today, it's not just that. You are getting bombarded by data from everywhere. If you are in a business of, let's say, providing logistics, there are sensors in your fleet that are bombarding you with data. If you are in manufacturing, there are sensors all throughout your production line that bombards you with data. If you are some online business, there are data that are coming from the online interaction that your users are doing on your website. So today, velocity of data has gotten much faster. So the estimate shows that the data grows about 10 times every 5 years, the amount of data that you have, right? But your data collection system that you build, usually when you are investing as a business in building a data collection and analytics and processing system, you are looking about at 10 to 15 years of shelf life. So that means when you are designing those systems, the amount of data that you have today is not enough. Because look at these two things, right? The system continues to work for 15 years, but every 5 years, the data grows 10 times. So that means what? You have to plan to scale for almost about 1,000 times of today's data. So that's why data collection is very important. How you can build a scalable data collection system that can handle the velocity of the data and accelerating speed of data that is going to come and bombard you with, and how you can effectively store those data. So storage is also another big cost driver when it comes to data, right? So that's why on Amazon we have different classes of storage, and not all storage are the same. Not all the data you can dump in a RDS database or like a MySQL or Oracle database today, because that's not cost optimized. So these are the things that your data engineer or your DevOps engineer needs to ponder before even when you jump into the machine learning, because handling the data in a more cost-effective way can make or break your machine learning journey, even though it is not directly related to machine learning, but it can actually add a substantial cost to your overall machine learning project that you are doing. And that's why you need to plan for the scale effectively at a more cost-effective way. So when I say cost-effective, what are some of the things that come to your mind? So for example, if you want to throw all of the sensor data that are coming every second or sometimes every millisecond into a relational database, can you imagine how many petabytes it's not even in petabytes we are talking about. I mean, it's cost prohibitive. You cannot do that. How can you do that? You have to use unstructured storage. You have to put those data in a lower cost storage like S3. Even on S3, all storage in S3 are not the same. There are different lifecycle policies that you can apply. There are different storage classes depending on how critical your data is, right? S3 in general have 11 nines of availability, right? But not all data needs to be available right away. Right? So for data that you need today, you can put that into a higher availability storage class versus the data that you do not need today, you can put that into lower cost storage, and maybe in Glacier as well when the data is done. So manage that whole data life cycle. And we have all the tools available. But like if I start talking about storage, that will be another whole day session, right? So these are some of the sources of the data as I talked about earlier, right? So production facilities, control device, IoT sensors, your web app, the click rates, and then external data coming from traffic monitoring camera, from weather sensor, and on top of your classic traditional data warehousing, historical data, logs, and archives. So what do we do with these data? We stream. Just checking on the time. So yeah, so we have these data streaming, or sometimes data can be imported in batch as well, depending on what sources the data is coming from. But the data as they come in, either in a streaming mode or in a batch mode, you will see that often you cannot directly apply that data to the machine learning because this data velocity is high. But think about it, there is an impedance mismatch between the machine learning need of data and the data that is coming in, because high velocity data is coming in. It's too much, right? Your model cannot understand all of the data before substantial input. Yes, machine learning does allow intelligence to your product, but in order to do that, first it needs your intelligence, your human intelligence, to understand what the data is. You have to take time. You have to slow down the speed of the data. You have to process the data, analyze yourself before even if you decide which model to build and how to feed the data. So first, you put the data in something we call data lake, right? Which is a very common term now. So what is data lake? So in data lake, you basically take the data as coming, you encrypt the data, you catalog the data, classify the data, and secure the data with proper access control. And then you do some pre-processing. Why is pre-processing needed? Because as I said, the raw data is not often useful to feed into your machine learning. Sometimes you have to maybe get rid of some features. Sometimes you have to create additional feature because of your model demands so. So one example, for example, I don't know whether you have done any linear regression. Maybe some of you have done, right? So when we do linear regression, which is a very common way of doing finding a pattern in the data. So the reason it's called linear regression is because we are basically trying to fit a curve where y equal to a1x plus a2x plus a3x and so on. So it's always a linear, like a straight line relation. That's the premise that the linear regression is depending on, right? But when your data is coming in, you are getting data from various sources, and you are trying to predict a certain outcome. Now think about the functional relation there. In real world is much more complex than a simple linear regression, right? But yet, we end up using linear regression to successfully model real world problem. And how is that possible? How can you use polynomial equation? How can you model polynomial equation or any, let's say, logarithmic using a linear data? What you do, the data scientist, they create transformation. They create transformation to create linear feature from your data that will approximate the polynomial model. So I'm just sharing that as an example, like why you need to do the ETL, the pre-processing, and that's where the ETL comes in. Now, if you do not do that in your data lake as a pre-processing step, you will end up actually doing that in real time when your model is getting trained. And again, that is going to push up your cost. So do not do any of these tasks alongside with your model training. Separate the two pieces. Separate the processing piece from the actual modeling piece. Do that in data lake. And the data lake, it does not have any constraint unlike a database. You can pull data from it anywhere in any format. You can push the data back in, and that's what the data lake are designed to do. With the data lake, you also have to do control and monitoring of your data, and your downstream application can also obviously consume the data. But my point of saying here is, what are the different AWS services that you can actually use to make that happen? So when you are importing in batch, how do you import the batch? You need the right kind of tools and services. So you can use, let's say you have a large amount of data that you want to bring in. You can use something called Snowball, which is basically an edge device as a huge machine that put terabytes of data and then ship the data onto AWS. You can also use Direct Connect if you want a high-speed connection between your data center to AWS platform, and you want to stream a lot of data. You can use Direct Connect, right? You can use database migration service if you have database somewhere else, and you want to bring it onto AWS as an RDS database or even as a NoSQL DynamoDB database. But all those methodologies for the import and batch does not really work well for today's high-speed data. They work well for your traditional ERP, CRM, accounting type data. For today's high-speed data, for example, those that comes from the IoT core, we have services for Kinesis, services like Kinesis Data Firehose and data streams that allows you to inject those high-speed data directly on your S3 bucket. And why is that important? Because of the velocity of data, you cannot use traditional importing tool. The data is coming so fast that you need to be able to scale that pipeline so as not to drop any data. With Kinesis, it automatically scales. It creates more shards, we call, which is basically like more highways in the road as your data volume grows. And it ensures that all the data is dropped into your S3 and there is no data loss. And then you also need to do some analytics. You have to understand what the data is, right? So for that, we have tools like Amazon Athena, EMR, Redshift, Elasticsearch, Kinesis, and QuickSight to analyze and visualize your data. And again, that is again a topic of another Analytics Week discussion, which will probably happen in Loft sometime, right? For machine learning, we have SageMaker, Recognition, Comprehend. So why are we using machine learning here? Because sometimes you need to use machine learning to prepare for machine learning, right? So sometimes you will need to use model to create some artificial feature, engineered feature, sorry, I say engineered feature, to be able to train another model. So you use machine learning model as part of your data lake pre-processing as well. Now, all of these sound like a lot of work to do. How do you tackle? Yes, I said there are a lot of these services available, but still it's too much, right? So how can we make these easy? For that, we created a service called AWS Lake Formation. So using Lake Formation, you can simply configure your data lake by pointing it to the storage that you are going to use, and the different sources, and the data catalog that you are going to use, and you can add the crawlers, so it will automatically go and crawl those sources and get the data from there, do the pre-processing within the pipeline. So once you set up, everything is automated, and you will always have fresh data available on your data lake that never goes stale. And with that data, once you automate all this pipeline using Lake Formation as part of, and by the way, this goes into that first 70–80% of the project lifecycle that I was talking about, right? So once you do that, the value add for Lake Formation is you do not have to keep going and doing it over and over again. You do that one time, you spend that time, and then you create a Lake Formation pipeline, and you are done. Your your system gets dumped by new data, but all the new data gets analyzed and pre-processed using the same pipeline to keep your data lake always fresh and up to date. Okay, so that was that. Collecting training data. So just one example here. Well, the company's name is here.com. They use Amazon Recognition to enrich the mapping content. It uses Recognition's text in image to allow continually update signage information so the customers have the latest information at their fingertips. So this is just one example of how a customer is using a high-level service called Recognition to add intelligence to their products or services. How are we doing on timing? Good, okay. So we talked about data. Now let's talk a little bit about what you can do with the data, right? So when it comes to machine learning, there are different broad techniques that you can apply. Supervised learning, unsupervised learning, regression. So first let's talk about supervised learning. When would you do supervised learning with your data? You will do supervised learning when this thing is available, which is called labels. Because what is supervised learning, in a sense, is basically very similar to just teaching good behavior to a child. You have to tell the child, okay, this is the action, this is the outcome, this is good, this is not good. And the child understands by repetition. That's what supervised learning is. Using a more mathematical type concept and a type example, let's say you have a black box. You don't know what is going on inside the box, but you can observe the input and output to the box. Let's say you are observing the data as they go in the box. Okay? So let's say when you input 2, the output is 4. When you input 3, the output is 6. When you input 4, the output is 8. You don't know what mathematical operation goes on inside the box, but you can observe the input and output, right? By observing the input and output, you can easily understand what is the function happening inside the box. In this particular case, is multiplying by 2. It was pretty easy for us to understand because it's a very simplistic example. When it comes to supervised learning, it's basically the application of the same principle. Instead of one number going in, now you have a data set with maybe hundreds or sometimes thousands of feature sets that are going in. But what is the output? What is the output coming out? You have to observe the output to understand how all these inputs are related and how they contribute to creating the output that you are observing. Now, that output is called label in machine learning term, right? So supervised learning is only applicable when you have all this feature set and you also have an output value that you can tell the machine, okay, if the data is this, then this is the output value. So for example, if you think of that famous example of house pricing data set, right? If you go to Kaggle, there's a Kaggle competition and there's a Boston house pricing data set, right? So what happens there? So the data set contains a lot of feature, which is a size of a house, how many square feet the house is, which location of the area house is, and so on. Now you want to predict what the house price will be. But in order to do that, first you have to have a lot of data with the labels. In that case, the label is the price of the house. In case of house, it's probably very simple to get that kind of labels data. You can probably write an API call, go to, let's say, Redfin. They have an API. You can pull this data, and you can create a label data set. Or in this particular case, you can just download. But you are not always so fortunate. You do not have the label data all the time. So if you do not have label data, then you have to create the labels for yourself. Now, because of everything that I said about the data, it becomes relatively cheap. But if you do not have the label, getting the labels, creating the labels can get very expensive very soon. And why do I say so? Because think about it. Let's say, actually going back to one slide before, let's say if you want to do this. Instead of house pricing, you want to do something more cool. You have dogs and cats images. You want to classify which one is dog, which one is cat. So if you think about it, this example is not very different than predicting the house prices, except the model needs to be much more complicated, because instead of having 10 or 20 properties of a house, now you have hundreds of thousands of pixel values with the intensities from an image coming in. But conceptually, it is not very different. It's all of these pixel values still going into a black box. And as an output, you are getting a decision, whether it's a dog, whether it's a cat, whether it's a human, whether it's a car, right? So there must be some functional mathematical transformation going in inside the box. We just don't know where it is. And that's where the machine learning will come in. But before we can ask machine to find the functional relation, we have to provide what the desired labels are for the data that we know what it is. So in order to create an image classification model, therefore, if you have a whole lot of images, then you have to send it to some humans to create these, classify the images first. For, let's say, 5 or 10,000 images you have to classify by humans, right? And there are models available. So there are models available. So there is this ImageNet model available, which have been labeled and trained on millions of images. And those are the good starting point. But then, even then, those models will not satisfy your need, because if you are in a business of, let's say I was working with a particular partner called Drone Deploy. So what they do, they have these drone imagery. And they want to use those drone imagery to train a model to find out when the drone is flying over what the drone is looking at. Is it looking at a building? Is it looking at a car street, any cars parked in? Now, yes, they want to use ImageNet model to retrain, but they have to retrain with their own image and with their own labels. They have to do something called transfer learning, right? Where the ImageNet model the ResNet model they take in, they shave off the top layer of the neural network, and they retrain that model using the labels that they have created for their own model. But how can they do that? They have a whole bunch of hundreds of thousands of drone images with all different kinds of things. They fly it over certain test zones of the city. Now they have to send this to humans and ask them, Mr. Human, tell me what you are seeing in this image. Identify which one is house, which one is car, which one is tree, which one is water body, and so on. And that becomes very expensive. Now, what did they do? When they came to us, they said, well, you don't have to do that yourself. You can use one of our partners, which basically provide this kind of labeling service through a feature of SageMaker called SageMaker Ground Truth. So labeling is expensive, and there is no denying the fact that labeling is expensive. So Ground Truth is a service that helps to manage the cost, but it does not drastically reduce the cost. So labeling is always expensive, okay? But what does it do? It basically streamlines the process and allows you to use different channels for labeling. So one is the public workforce, which is Mechanical Turk. You might already know about Mechanical Turk, which is basically a way to send certain micro tasks to human workers using API call, which existed even before SageMaker and all this machine learning came into play. So in SageMaker, what we did is we added this feature called Ground Truth, where behind the scene, you can use Mechanical Turk task force to send certain tasks to do labeling on the image, classification of the text, and so on and so forth. And we provide certain built-in templates that makes your setup of task easy. The other option we also provide is, let's say you have some cycles within your own company, within your own employees, and you want to use those idle cycles from within your organization and ask them to create your levels, right? So you can also do that using private workforce on SageMaker Ground Truth to reduce some of the cost of using public workforce. We also have contracted workforce, which is basically the vendors. So if you go to AWS Marketplace today, you can find vendors who specialize in this kind of leveling job. And you can contract your job out to those vendors, again, through SageMaker. SageMaker Ground Truth basically provides that API level integration. Even though you are using the vendor or public workforce or your own employee, it provides the exactly same API level integration. So the data goes in from your data lake to the workers, gets leveled, comes back with your data set, and all good. And then you can even set a trigger that when, let's say, 10,000 image is leveled, therefore start your training job. You can do all of those automation using this API level integration that you have on Ground Truth. I will provide you all the links. Yeah. Let me just finish quickly, and then I can take questions. Yeah. So you will get the slides here. So it's Amazon SageMaker Ground Truth. If you log into your AWS console today, just go to services and look for SageMaker. You will see the Ground Truth as the first piece there, and it will provide you some sample templates. So you can get some images like from, let's say, some of those ImageNet images, and you can create a sample task. You can assign it to yourself also. You can create a private workforce with a single worker, which is yourself, and you can assign it to yourself, and you will see how SageMaker sends these images your way. In your email, there will be an email coming in with a link where you go in. It will basically show you all the images and which you click and then select from the levels. So collecting and labeling your training data. So once that is done, then you go on to create and train your models, right? So in order to do that, you have SageMaker. So you have, so there are basically, other than Ground Truth is basically the first one. Then once your data is labeled, you have three distinct features that are available on SageMaker. Number one is the hosted notebook, which is basically what a data scientist typically does using on his local machine. It's basically just a development environment specialized for machine learning development, right? So why is that necessary? Because before you submit a training job for hosted training, for managed training, your data scientists would typically need to experiment a little bit about the data, like kind of the thing that you have done in the data lake pre-processing stage as well. But once the data is available, feature engineered data, then your machine learning engineer or data scientist would actually need to try out those kind of statistical methods. So that's where the Jupyter Notebook, the hosted version of it, comes into play. Once you know that, okay, your algorithm works, you have the container ready, then the second feature we offer on SageMaker is called hosted training, where you submit the training job with your data. We point your data to your data lake, which is an S3 bucket. You choose an algorithm or provide your own algorithm as a container and ask SageMaker to go and train. Now, once you do that, SageMaker goes away. It creates the number of EC2 instances behind the scene, which you don't see, by the way, on your EC2 console, because it's all managed by a SageMaker. It's provisioned just in time. It creates the EC2 instances, runs the Docker image container inside the machine, and then gets the data from your data lake, trains the model, and once the model is trained, it saves the model back into your S3 bucket and automatically spins down all the training infrastructure that was created. So not only it helps speed up the training, it also helps you curb the cost, because if you want to train a model, let's say, with terabytes of data, you might need a M416 extra large machine. Now, if you if you want to give that machine to your data scientist, he's going to play with it. He's going to have fun time with it. But at the end of the day, you will be the one who will be footing the bill for that M416 extra large, right? So instead of doing that, you can give him a smaller instance so that he can use the same libraries but play with a smaller subset of data. But once you prove the concept, then you can submit for a full-scale training with a production-scale data with a higher instance with the right instance type. And at that point, you are not worried about, oh, when the training is over, am I going to have to pay, or do I need to go and shut down the machine? You don't have to do any of that, because SageMaker will do that automatically on behalf of you. It will bring in the instances right in time. Once done, it will spin down. And then the last and final part in SageMaker is model deployment, which basically is, it's not part of the machine learning pipeline as per se, but it is also very important because without a production scale deployment, once you have your model, think about it, your model, you are building that model because a lot of stakeholders are going to use that model to get decisions, to do prediction, regression analysis, classification, image classification, clustering, and a lot of things. So who are going to, how does that happen? So the model is a static artifact, but in order to bring the model into live, it has to run on a machine, an instance, and behind an API, right, where the request will come into your model. And this downstream application, the consumers of your model, will send a lot of traffic to your model. So you need to also be able to build the deployment in a way that is scalable, automatically scalable, right, depending on your needs, because again, we always advise our customers to be cost concerned. So in SageMaker, what you can do is you can do a load testing of your model. You can create some sample load to see what kind of traffic is generated. And there are load testing tools available that you can use to figure out the right instance type for your model deployment. And once that is done, then you can create a configuration for your deployment with however many instances that you require. Let's say you do a load testing, you do the benchmarking, and you think that, OK, we'll need a 2 ML extra large instances for our model. But at the same time, there are some spikes that can happen on certain times or days of the week. Therefore, we need to have the automatic scaling capability behind my model that can go up to from 2 to, let's say, up to 5 instances. And you can do all of that using SageMaker. You can do that automatic scaling. So that's about it. Now, in looking at the time, I want to stop here and give some time for you guys to ask some questions. I heard there was one question coming from here, gentlemen, and you. OK. Yes. Oh. No. So the question is the connection between the diagram I showed and the CloudFormation stack that you were launching at the beginning of the session. So there is no connection for that. So what we are discussing this morning, it's all about understanding at a high level holistically what machine learning can do for your business. But the workshop that we'll be doing next is just to have some fun time. So we are going to build a chatbot using Lex as a voice service, and we will basically make a little app that you can put certain quiz-type questions in, and you can use your own voice to ask question, and it will respond back to you. So that's a very different exercise from what we are doing now. Mm-hmm. It is. So let's hold on to that when we go to the second session. Yes. Yes. OK. That's a very good question. So the question here is, what is basically the relation between Forecast and SageMaker, and why Forecast is a different service, right? Why Forecast is not part of SageMaker? So if you think about it, SageMaker is a general-purpose machine learning platform that allows you to analyze data, run any code that you want. It's not just machine learning code. Basically, any Python or R code you can run on SageMaker. And then you can create your own algorithm or use our provided algorithm, but with a lot of hyperparameters that you can tweak. But then, using SageMaker, you have to decide which algorithm to use. So at the end of the day, SageMaker gives you a lot more control than a more managed service like Forecast. Now, if you ask the question why Forecast is a different service, the answer to that comes to customer's choice. Because not all companies are at the same level of maturity when they do machine learning. Some companies have strong data science team. They want to do a lot more. They want to actually get their hands dirty, create those models. They understand what the statistical process is, and so on. So they will use SageMaker. There are some companies, they understand some, but they, at the same time, they do not want to write their own code to train the model. They will still use SageMaker using one of our built-in algorithms on SageMaker. Now, even though you do that, you still have to do quite a bit of DevOps stuff when you are doing SageMaker to set up the pipeline and all. Now, there are some companies who doesn't want to do any of these. All they want is, I have the data, I want the answer. I do not care about setting up the pipeline. I do not care about deploying the model, automatically scaling my production endpoint. I do not want to do any of that. I simply want me to give me the answer given the data that I have. And those are the customers that services like Forecast is made for. Yes?
There was a little thing about when you were discussing the tagging or labeling of the data.
Uh-huh.
There was a little thing that said active learning. Is that a service?
Good point. Yes. So in my ground truth slide, there was a feature called active learning. Well, I didn't get into the details of ground truth because that's, again, a separate talk that we offer. Now, active learning in ground truth is a feature where machine learns alongside humans and do the labeling. So let's say you have 1,000 cats and dogs images that you create a job and send to human workers. So if you turn the active labeling feature on, what SageMaker will do is it will probably, let's say, send first 50 or 100 images to the human workers, and it will see the confidence score that it is getting from the human worker. And it will, without any of your input, it will automatically train a model inside SageMaker itself, and this is not a model that you are specifically training. SageMaker sets it up internally for you and tries to see whether there's a strong correlation between the input and output in certain cases. And then for the rest of the input data, if it sees that it can have a very high confidence factor, then it will do the labeling itself and not send those to the human workers. So if you do that, then you are basically saving on cost as well. So now with this feature on, instead of 1,000 images being labeled by human workers, maybe only 500 or 600 will be labeled by human workers, and then the rest will be labeled by the machine itself, only when the confidence factor is high. Yes? Uh-huh.
So if the attributes are, once you take that within the forecast, if the attributes are assumed to be in certain order, like I saw some list of attributes for one model, like 5 or 6.
Mm-hmm.
That's the format you have to give. Is that format?
So the attributes, so the question here is about the attributes of.
You take it generic within that.
Right.
You can do random ones, and then it will figure out what is applicable.
So let's take that question offline. I think we have some break, and then we can move on to the next workshop. So this is not specifically about forecast, but since you have the question, I can always talk to you offline. Huh?
Is there a quality process in labeling? How do you know that the labeling the human does is accurate?
Let's also take that offline. I just want you guys to give a little 5 minutes quick break, and then before jump on to the next session, which is the workshop, by the way. And meanwhile, you can check if your CloudFormation stack is ready, and then we will jump right in. And then I'll take your question offline as well.